Good day everyone, I am Carmelo Pilos. Now, we are going to solve one of the problems of the chapter 3 entitled Torsion, specifically the problem 3.121. So let's define first the torsion. Torsion is the twisting of straight bar when it is loaded by a twisting moment or torques that tend to produce rotation about the longitudinal axis of the bar. When the body is subjected to a twisting moment, which is commonly referred to as a torque, that body is said to be the torsion. Knowing that the magnitude of the torque T is 200 Newton meter and that the value of shear modulus of rigidity is equal to 27 gigapascal, determine for each of the aluminum bars shown the maximum shearing stress and the angle of twist at NB. So for the part A, which is the upper portion, calculate the ratio of width and thickness of the aluminum bar of rectangular section. So in the problem, the thickness is 15 mm and the width is 45 mm. So in order to calculate the ratio, it is equal to width over thickness. So 45 over 15, it is equal to 3. The next thing to do is to obtain the coefficient of aluminum bar from looking on the table 3.1 in the textbook. So at ration 3, the coefficients are as follows. C sub 1 is equal to 0.267 and C sub 2 is equal to 0.263. The next thing to do is to calculate the maximum shearing stress by using this relation. Here, T is the largest torque. Now we have the C1 and the width and the thickness. Substitute, we will get this answer. So the next step is to calculate the angle of twist at the end by using this formula. Here, L is the length of the bar and G is the modulus of rigidity. So substitute 200 for T, 0.9 for L, 0.263 for C sub 2, and 45 mm, 15 mm for A and B respectively, and 27 GPa for G. So the angle of twist at the end is 9.56 degree. So for the part B, which is the lower aluminum bar, we will do the same thing like we did on the part A. So in the problem, the thickness is 25 mm and the width is 25 mm. So the ratio is equal to 1. Now, look at the table 3.1 in the textbook, and at ratio 1, the value for C sub 1 and C sub 2 respectively are 0.208 and 0.1406. Now, calculate the largest torque that can be applied using the maximum shearing stress relation, where T is the largest torque. Now, substitute the 0.208 for the C1 and the thickness and width, which is 25 mm, and the torque is 200 Newton meter. Now, input will arrive at 61.5 megapascal. So similarly, let's calculate the angle of twist at the end by using this formula, where L is the length of the bar and G is the modulus of rigidity. So substitute 200 Newton meter for T, 0.9 m for L, 0.1406 for C sub 2, and 25 mm for B and A. Then G, which is equal to 27 gigapascal. So input will arrive at 6.95 degree. That's it.